Greetings, math fans. All right, so this is chapter 9, day 1. So we got chapter 9, day 1. And basically what we're doing is we're going to be graphing quadratic. So graphing quadratic inequalities. And basically we're going to be doing this on a number line. Okay, so even before we kind of get started, let's just review a little bit about inequalities because we've learned this already, but just a good thing to kind of review it, okay? So remember, if you have a greater than sign, first of all, this is greater, right? It's, well, I'll show you a little way to remember this a little bit here, but that's, and this is a less than. Because if you think about it, look at there, here's an L. Watch this. There's an L, right? Less than. If you kind of look at it, oh, it's a less than. And people are like, well, what about the greater than sign? Does that look like G? Well, watch this. G greater than. I don't know, whatever. Okay. But this is definitely a greater than symbol, and this is definitely a less than symbol. Okay, really, really important. And if you guys remember, we actually did this back in the day with absolute value, okay, where we would set up a problem like this, and I'm just going to do this in green, okay? But if it's a greater, it's a great, I'm going to write this great, or, and if you guys remember what an or problem looks like, it looks like it points out this way and out this way, just like a set of oars, right? Right, oars on a boat, they point out, okay? So that's great or, if you can remember that, great or, and then if it's a less than, so less than, is always a barbell. Okay, I don't know if I have a creative, I'll think of someday a creative way to do that one. But that's always a barbell, or it's, if you want to say, so barbell, or it's a between problem. That's actually an important word too, between. Okay, so if it's a less than, it's between, which makes it a barbell. If it's a greater, it's an or problem, and it's or, so it points out. Okay, that's what you have to remember. This is actually really, really key. So, you know, this is like super highlighted here. Make sure you know how to do all this stuff, right? Okay, and recognizing whether something is less than or greater than, and then what it is. So if you remember that, less than is a barbell, and it's between problem. Greater is or, and you have two ors pointing out. Okay, if you can remember that, you're going to be good with this, this part of the unit here. Okay. So let's talk about how we're going to actually deal with inequalities. So if I do a problem, this is going to be factored for you. So I'm just going to, most of the problems are not going to be factored, but let's start out with a factored problem. X plus 2, x minus 4. Okay, and that's greater than 0. So here's the deal. The first thing you do is you're going to look at this, and you're going to recognize that, and you're going to say, oh, it's an or problem, great or. And this is after it's been factored. Okay, so this is an or problem. So I know my problem is going to look like this and like this. Okay, because it's an or problem. All right, so I'm going to solve for x. X equals negative 2. When you can subtract 2, you guys are all good at that now. And x equals positive 4. So what you're going to do is you're going to plot that on the number line. You're going to say negative 2 and a 4. And you know it's an or problem. So, and by the way, if it's a less than or greater than, remember that's an open dot. Open dot. Okay, and if it's less than or equal to or greater than or equal to, it's a closed or a filled, sometimes we say filled dot. Okay, so this one is greater than, so it's going to be an open dot. So draw some open dots, and since it's a great or, it's going to go this way. Okay, that's the graph of this, of the solution. So we're halfway done with the problem, and so basically what you're going to say now is there's going to be an answer blank, and you're going to say x is less than negative 2 or x is greater than 4, and that's your answer. Okay, so really it's not that bad, but you got to say x is less than negative 2 or x is greater than 4. Okay? Pretty easy, right? All right, let's do another problem. I got a bunch of problems to do with you guys, but really what you're doing here, guys, is you're solving for x, you're plotting those points, and then you're looking at with the inequality sign, and is it an or problem or is it a between problem, and then you graph it. Okay? So let's do that exact same problem. If it was, so I'm going to say exact same problem. So you can compare the two. Let's say it was that, except it was less than 0 instead of greater than 0. So you're going to have the exact same points, x equals -2 and x equals +4. And you're going to plot those, -2 and 4. And again, I'm going to plot the points, they're open dots. And because it's a less than, it's between. Okay, you got to know that. If it's a less than, it's between. If it's great or, it's an or problem. Between means barbell. BB, barbell between. Okay, and then on the answer blank, you are going to write x is between -2 and 4. It's always going to point this way, by the way. Maybe I'll make this a little bolder here. No, I'll make it in green. These will always point that way. So this should be on your note sheet. Those inequalities should point to the left all the time. They will never point any other direction for these problems. Ever, ever, ever. They're always going to point to the left. Just like that. Okay? And that's your answer to the problem. So that's it. So this right here, that's the graph answer, and that's the inequality on the answer blank answer. Okay? It's not bad. Let's do a couple more here. So let's do ones that are not factored yet. So let's go with x squared plus 6x minus 16 is greater than or equal to 0. Okay, so we need to solve for this. I'm going to bring this up right now because I think it's important. This always needs to be positive. If it's not, you divide everything by -1, and then it will switch your inequality sign around, which I'll do in a little bit here. But I just want to stress right now, that term has to be positive in order to do this problem. Okay, so what I'm going to do is I'm going to do a factor box. And I'm going to get x squared and -16 and 6x. So I get x and x. And 16 is going to be 8 and 2. That's going to be 8x and 2x. And then it's got to be a positive 6x, so this one's got to be negative, right? To make it 8x minus 2x is 6x. And so basically, and again, you might be factoring a little bit different depending on what you do here, but I just did the factor box, so you should know how to factor. Okay. So it's going to be, if I factor it, it's going to be x minus 2 times x plus 8 is greater than or equal to 0. So you guys should recognize right away, greater, this is going to be an or problem. So I know my problem is going to look like this, and it's going to say whatever this value is, x is less than that value, and x is greater than that value. I pretty much know everything except I just need the numbers. So I'm going to get x equals 2 and x equals -8. So we plot, and make sure you don't plot 2 on the left. You guys should know you got a -8 here and a 2. Okay? All right, and these are solid dots, by the way, so solid dots. And then I point to the right and I point to the left. So that's the graphic answer. And then the written answer is really easy. It's just look at the graph. X is less than or equal to -8, or x is greater than or equal to 2. And that is the other part of the answer. Okay? It's not bad. Not bad. If I had this exact same problem, except, so let me get rid of the some of the stuff here. If I had the exact same problem, except instead of it being greater than, it was less than. So just to compare it, so x squared plus 6x minus 16 is less than or equal to 0. So you're going to do all the same work here. All the stuff right here is the same. Okay, and you're going to get those two answers. You're going to get x equals 2 and x equals -8. But now you know it's a less than, so it's a between problem. So I'm going to draw -8 and 2. I'm going to draw solid dots. And instead of being or where it goes to the right and left, it's going to be between, just like that. So that's the answer for the graph. And then you're going to say, as an answer, on the answer blank, you're going to say x is between, just like that. Always, 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 pointing to the left. Always, 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 always. Okay, -8 and 2. And that would be your answer. So that's just, again, to compare, one's a less than and one is a greater. Okay, it's not too bad. Okay, so let's take a look at a problem now where we have a negative in front. Okay, so let's say I have negative x squared plus 5x minus 6 is greater than or equal to 0. All right, so the very first thing is you got to look at this and you got to say, oh wait, you cannot have negatives. Okay, so no negatives. It's huge, huge, huge. You can't factor it. You have to get rid of the negative. So what I'm going to do is I'm going to divide each term by -1. That gives me x squared minus 5x plus 6. And now remember, what do you have to do with this inequality? Right now it's greater than or equal to. What do you do when you divide by negative? Super important. Okay, you flip around the inequality sign. So it's really, really important, and that gives you less than or equal to 0. Okay, now I can do the problem. All right, so let's go ahead and factor this baby. And again, you can use whatever method you want to factor. I'm just going to do it. Okay, and I get x, and I get x minus 3 and x minus 2 equals 0. Okay, so x equals 3 and x equals 2. And I know that it's a less than, so I know it's a between problem. Again, please do not look at this one. All right, that would be greater, but you had to divide by that negative, and then you got it turned into a less than or equal to. This is where you make the decision, guys. Right here is what to do. Not before, when you have a negative term or negative x squared. Okay, so let me go ahead and graph it. So I'm going to put 2 and 3, and it's a between problem, so it's a barbell, and there's solid dots. And it's a barbell. There we go. That's that answer. And then the answer on the answer blank is x is, and again, the inequalities will point this way. Always, 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 always. And then you just fill it in, 2 and 3. And there we go. So this is the answer to that problem. Okay, so remember, make sure you divide by negative and flip around that inequality sign. Okay, very, very important. Let's do one more here, and then we got to get to 2 special cases. Okay, so I don't want to scare too many people here, but it's not that bad. All right, so if I gave you guys 2x plus 3 is less than or equal to x squared. So remember, when you factor, guys, everything has to be on one side. Now, personally, I would move the x squared over. And if you decided to move the 2x over instead, I'm going to show you both ways, okay? But I'm going to show you the things that you have to do. So I would move the x squared over. So subtract x squared from both sides, and you get negative x squared plus 2x plus 3 is less than or equal to 0. Okay, then you have to divide by -1, and you wind up getting x squared minus 2x minus 3 is greater than or equal to 0. Okay, got to flip that inequality sign around. So now we're good to go. Now we can actually factor it. So here's the deal. Instead of doing that, I could have done this. 2x plus 3 is less than or equal to x squared. I could have subtracted the 2x and the 3 from both sides. And you'd get 0 less than or equal to x squared minus 2x minus 3. Now, you can't solve the problem this way. You have to flip it around. This has to be on the left side. Just like you don't leave anything like 5 is greater than x, you say, oh, x is less than 5, right? And notice the inequality is pointing to the 0. So if I rewrite this, it's x squared minus 2x minus 3. And see how it's pointing to 0? So I'll have it point to the 0. Okay? So I got the same thing here, guys. I don't know what's easier or not. I think the left side's easier, moving move the x squared to the correct side and then deal with the negative and flip the inequality sign around. Okay, but if you don't do it that way, if you do it the way I did on the right here, when you change this around, it's pointing to the 0. So when you flip it around, make sure it's pointing to the 0. Okay, so if I factor this, I get x minus 3x plus 1 equals 0. So x equals 3, x equals negative 1. So those are my two values, and so I'm going to put and plot those. Negative 1 and 3. Okay, and then, well, how do you make the decision? Well, let's take a look. Greater, so these are solid dots. And it's an OR problem, so they point this way. And then if I want to write it, it's x is less than or equal to negative 1, or x is greater than or equal to 3. Okay? So it's not too bad. Again, make sure that it is a positive value and you're not dealing with negative value, because it won't work. Okay. I have two special cases, math fans. So let me do both of them. They're really pretty quick special cases. All right, so let's say I had x squared plus 6x plus 9 is less than 0. So you go ahead and factor. So you wind up getting x plus 3, x plus 3. And by the way, this is less than, so it's definitely a between problem. Okay? Or barbell, right? So the deal is, what do you notice here, math fans? This is the same. So really, I get as an answer x equals negative 3. I have one answer. So the way it's going to work is I still have to graph it. And this is x equals negative 3. And here's the deal. It's an open dot, first of all. And you're supposed to graph between it. Guys, there's nothing to graph. I have 1 point. So there is nothing between them at all to graph. So the answer to this one is no solution. Because there's nothing to graph. I can't graph between an open dot and nothing. Okay, so it's no solution. This will not work. No solution. Again, this is if you have the same number. If this is x equals negative 2 and negative 3, now you can do a between. If it's not, if you can't do a between, think logically. You can't do this between, so it's going to be no solution. Okay? So if I have this exact same, almost exact same problem, so let me write this on the side here. So let me just draw a line here. If I had x squared plus 6x plus 9, and we'll say greater than or equal to 0. Okay, same factoring. So x plus 3, x plus 3. So x for both of them is negative 3. And remember, it's greater, so they point out. Now the deal is with this one, if I plot the negative 3, and by the way, this is a solid dot now, if you notice that. Or means you draw ORs. So here it is. Let's draw the ORs. Okay, so what does that mean? That means it's all real numbers. It's everywhere, right? It's that dot, and it's to the right and to the left. So this is all real numbers, which you can say double bar R. All real number. Every number works in this one. Okay? So again, if you have the same number for both, then it's one of those special cases. Okay? And it's pretty logical when you think about it. If it's a less than, if it's a between, you can't go between when it's just one value. And if it's an or, it's everything, because there's no left or right number. It's just negative 3 and everything with it. Okay? So that's it, math fans. That's graphing quadratic inequalities. And it's really not that bad. Just make sure you practice. Make sure you know betweens are less than, and greater, that's an or problem. It's greater than problem. And then the special cases. All right? That's it, math fans. Have an outstanding day. Adios. Goodbye.